Welcome students to the Electricity Fundamentals video series. This is the first video in the series, and today we're going to talk about just voltage.
So voltage, or more specifically in automotive, we're talking about DC volts. Okay, and the V with the solid line and the dashed line on top is the symbol that we use on our meters when we are measuring DC volts. Okay, which means the voltage is only traveling in one direction. Okay, AC voltage sort of goes forward and then backwards. All right. Now you might ask yourself, why do we need voltage? What is really the purpose of this? At least I'm hoping you're asking yourself why we need voltage, because it is very fundamental, but it's also one of the most difficult concepts to understand. But if you can understand voltage, you're pretty much good to go in mastering the other measurements. Okay, so all voltage is pressure. It's pushing down, let's say, just as a good visual, okay, on our little bitty electrons. Okay, and the electrons are the ones that do the work. They're like people. Okay, now the voltage, interestingly enough, doesn't actually move. It's just sort of there. You can also think of voltage as a weight. Okay, imagine like a giant boulder. It's very heavy, but it's not necessarily moving anywhere. Okay, but you sort of need a little bit of pressure to get those electrons to move. And that's really the main objective, is to get these electrons moving. It's kind of like when we get up in the morning, we really need a little bit of pressure from, maybe someone in our household that sort of tells us, hey, it's time to get up, time to go to school, time to go to work. Don't lay around the house all day. We got to make some money, okay? So these electrons, they need a little pressure to get out of bed in the morning and go and do some work. Okay? Now, in an electrical circuit, work is performed by these electrons, or these little imaginary people running around a circuit. Okay? And they're going to perform work on a load. In this case, we're just going to use a simple light bulb. All right? So these electrons, they pass through this light bulb with sufficient amount of pressure or sufficient amount of voltage, and the light bulb does this wonderful thing, and it lights up. We have 12 volts of pressure before the light bulb, but you know what? Once the work is done, the pressure goes away. There's just no need to have any pressure. Okay? So then after the bulb, there's only 0 volts. So what do the electrons do after that? Well, they do what most of us do after work. They go home. All right? But the big question is, where is home for electrons? Okay? Well, if you think about our everyday life, we start from our house. And in automotive, where would we store electrons? Well, our storage device, also known as a battery. Okay, so that's a terrible drawing of a battery, but hopefully that doesn't bother you too much. Okay, so out of a battery, we have a positive side. This looks a little upside down, but that's not really a big deal. Okay, and we have a negative side. Now, when we're talking automotive, we like to say that the electrons come out of the positive side. Okay, oops, let me make that the correct color. They come out of the positive side. They go to work. All right. Lighting the light bulb, and then they're going to go right back to where they came from. Okay, which is back to the battery. All right, it's a circuit. That's why we call an electrical circuit a circuit, because it just goes around in a circle. All right? From the battery to the load and back up to the battery. All right? So now let's draw this diagram to resemble something similar to an actual schematic or a wiring schematic. Okay? In a wiring schematic, we're going to have the positive side of our circuit indicated by typically a plus sign, or you might also see a B in front of it, which means battery positive, something that comes straight from the battery. Okay? And then we'll have a wire that goes around to, not the load, not yet. First we've got to go through a fuse. Okay? We really need to make sure that we have a device in place to protect us if the electrons are moving too fast, because at that point you could actually blow a circuit. Okay? So we have this nice little fuse, all right, and in an electrical diagram or schematic, it usually looks something like that. Okay? So after the circuit protection, we come around, and then we get to our load. All right, here we go. Here's our load. Here's our light bulb again. All right, I'm sure you remember that. And now you might imagine that the electrons want to travel back to the battery, okay, or ground. And ground is represented sort of by this little triangle symbol. You might also see it in this form, and that looks just kind of like a little rake. It's kind of odd, but you know what? It works, okay? But there's something this circuit is missing. We can't quite complete it yet. Ask yourself, do we want this bulb to be lit all the time? Well, most likely not, okay? You don't want your brake lights to be on all the time, even when you're not in the car, because you would use up all your electrons, okay? We don't want that. So what we like to install is a switch. And we can really put this switch anywhere in the circuit. It doesn't matter, okay? And then the electrons travel back to ground, okay? If you want, you can imagine that we have a little battery here, okay, as your positive and your negative, okay? So hopefully that sort of helps. But remember what voltage is doing at all times. Anytime you read a schematic, you want to think about voltage before you think about really any other measurement, okay? We know that the battery should automatically have 12 volts at least, okay? And we know that, well, the fuse, well, that, you know, that doesn't take much work to get through, so we shouldn't have to use too much voltage, okay? We should have 12 volts before the fuse, 12 volts after the fuse. We should have 12 volts. I'm sorry, let me correct that a little bit. We should have 12 volts before the bulb, and after the bulb, well, that's our load, okay? Remember how much work those electrons put in to get this bulb lit up? Okay, so after the bulb, we should really have close to 0 volts, or close to no pressure, however you want to put it, okay? All the pressure has been lost through the bulb or through the load because, well, the electrons used up all the pressure to get the work done, okay? And now they're tired, now they're going to go back home. And we're going to continue to see no pressure all the way back to ground, okay? We really shouldn't see any voltage on the ground side. Oh, I'm sorry, you have a tough time seeing that, okay? Because the pressure has been used up by the load. If you do see voltage on the ground side of a circuit, that usually indicates a fault. So for our on-vehicle testing, we're going to be focusing on low beam headlights. Okay? And the headlights work fine, but we're just going to test what is normal so that you understand what a normal system looks like. If you know what's normal, then you know that
all other readings outside of that are abnormal and that you have identified a problem.
The first thing that you want to do when diagnosing any system is check the battery. Now, how do we check the battery? Well, for the most part, you would use a battery tester that just simply hooks onto the battery positive and negative cables and test it that way. But also, a slightly more convenient way is to use your multimeter. Okay? Now, as you can see here, I've set my meter to DC volts. All right, just remember the solid line with the dashed line and the V underneath. And I've connected my meter leads to common and volts. Okay, common is also referred to as ground, and of course in this jack you're going to be testing volts. Don't worry about the other stuff, we're just focusing on volts today. So I can go ahead and set my meter down. Take my meter leads that were so delicately placed. Alright, now I have my red meter lead, the positive lead, and my negative lead, which is the ground lead. Now, you can hook this up backwards, and it really doesn't matter. You're not going to damage anything. You'll just simply get a slightly different reading than you probably desire. So let me just set this up here so you can see that well. Okay. And all we have to do is touch our negative post and our positive post and see what we get. So we have a reading of 12.4 volts. Now that's okay. It's not fantastic. 12.6 volts is really ideal, 12.6 and above, but 12.4 is adequate. Okay, so we know that our battery is good. Next, we want to check all of our fuses, and we're going to do that using a test light. And actually, you can diagnose a lot with just a test light. So first you want to remove the cover for the fuse box. And we know that electricity is a complete circuit. And if we want to light up this light bulb on our test light, we have to have a complete circuit in order to do so. So if we're testing for power, which all these fuses should have power on both sides, then we're going to want to connect our test light clip to the negative cable. Okay, make sure that's on there well, and we just want to make sure that our test light is operational by touching the positive battery post. Okay, it lights up. Great, so we know that our test equipment is working properly. There's nothing worse than having a test light that's not working for you, and then you end up trying to diagnose things that don't actually have a problem. Okay, so what we're going to do is on all of these small fuses, we're going to just touch one side of the fuse and then touch the other side of the fuse to make sure that it's good. Now you might be wondering, why can't you just touch one side only and go on down the line and check it that way? Well, there are two terminals on these fuses for a reason. If you look at this fuse here, you'll notice that electricity is going to flow in one side and come out the other. And hopefully you can see this, but this fuse is actually broken right here. So you could have voltage coming in all the way up to the top testing terminal. Okay. And let me focus. Okay, all the way to the top test terminal. And inside the voltage would flow all the way to the end. But of course it can't jump that gap. We need to have a connection there. So on the other side here, you will have no voltage. And that's how you test a blade type fuse. So let's go ahead, So let's go ahead and check all of our fuses. Key on is preferable. Now, you notice that if we're checking a specific circuit, such in this instance, we are checking a headlight circuit, I'm not just looking for the headlight fuse. I'm checking all the fuses. It's best just to check all of them because we don't quite know yet what circuit interferes with what circuit. Now sometimes we get a fuse like this one that doesn't have any power to it, and that's okay. Some fuses will not have power to it unless a certain switch is activated, such as maybe the vehicle needs to be running instead of just key on and in park, or maybe the vehicle needs to have the key in the accessory position. Okay, if we are concerned about that fuse, then we can check it at a later time. Okay, so I have continued to check all the fuses. They're all good. Okay, now if you are wondering, how can you tell what fuse is what? Just in case a fuse was not activated, especially if it is for a circuit that you have a concern on, such as, in this instance, the headlights, then sometimes under the cover they give you a nice little diagram of all the different fuse positions and what those fuse positions mean. Okay, sometimes you have to actually go into All Data or another service information provider and actually look up what fuse goes to what circuit through a schematic wiring diagram, or they may even provide this same exact diagram for you in service information in case, as time goes on, vehicles get a little older, these little things tend to fade or become missing. Alright, so in this instance, I know that my low beam, left hand and right hand low beam, are 10 amp fuses, 65 and 66, which are right over here and here. If I orient my diagram properly, I can see that 65 and 66 are right in the back next to these relays over here. Okay, and I did double check those, and they're all good to go. Now, just to bring home the whole idea of available voltage, I'm going to actually replace my test light with a multimeter. Most of the time, if you're checking available voltage, a test light is pretty adequate. Okay, but just for practice, I'm going to go ahead and put my negative lead on the negative battery cable. Okay, just like a test light would be hooked up. Let's see if I can get it to stay there. Fantastic. Okay, and I'm going to go ahead and check my meter. So we're good. We're at 12.404 volts now. Sorry, we're at 12.04 volts now. That's because the key's on. It's been on for a little while, and our battery is starting to drain. So, sorry, Daniel. Okay, so I'm going to go ahead and check my fuse on one side. We have 11.99 volts on one side. And let's see if I can get this on there correctly. Oh, I almost had it. There we go. And 11.96 volts on the other side. Now you might be wondering, well, we had 12.04 volts coming from the battery. Why didn't we get all of that voltage to the fuse? And why did the fuse lose some of that voltage? Well, that's because of something called voltage drop. Okay? Anytime there's a load in the system, you're going to use up some voltage. Okay, you're going to have some pressure dropping. Now, we don't have a huge load between the battery and the fuse box, but it takes a little bit of effort to get the electrons through the actual power circuit to the junction box, and it takes a little bit more effort to get the electrons to go through the actual fuse. Okay, it's not a lot. It's very, very negligible, but it's still there. Just be aware that, as long as we're within 0.05 of a volt, then we're generally okay. For such a short circuit like this, I mean, really, a few hundredths of a volt is all right. Okay, we're not gonna worry too much about that. Okay, so we're done checking fuses. We've checked the battery, everything looks good. So now we're going to go ahead and go straight to the next accessible component, and that's actually the right-hand headlight. And this is the area of concern. This is the headlight that we want to test because let's say the customer is complaining that sometimes their right headlight doesn't work so well. Now, you may notice that there's 3 wires there. Now, we're used to maybe 1 wire for power and 1 wire for ground on a component, but here we have 3 wires, and let me tell you why. In this bulb, we have a high beam filament, which is brighter, and we have a low beam filament, which is less bright or not as bright. And if we're going to test for something properly, then we need to know which wire goes to what. So what we're going to do now is take a look at our schematic. Okay, so here is our headlight schematic, right? So if you're looking at the headlight schematic, the first thing that we're going to look at is the components, which are located right here. Okay, this is our right headlight. This is the subject of our problem, the subject of our concern, that maybe this right headlight is not working so well. Okay, so what we're going to do is start from this component, and we're going to work our way to see where it gets power from, and then we're going to see where it gets ground from. Okay, so I tried to zoom in on the schematic a little bit for you. Right now we're really just going to focus on the power side, or where our component gets its voltage from, its electricity from. So we're going upstream, so to speak. All right, so we know that we start right here at the right headlamp bulb. Now I know that a lot of this looks kind of like a really big jumbled maze. We don't need to worry too much about it. Okay, I'm just gonna break this down for you. One of the first things I'm gonna do, just so we don't freak out too much, is draw a line and blocking this whole lower section. Okay, let's not look at that. That is actually the module, our body control module, and we don't want to focus on that too much, okay? Right now we're really just concerned about where we're getting power from, okay? And this system does have relays, so again, let's just kind of keep it as simple as we possibly can as far as headlight circuits are concerned. Basically what we're going to do is wiring diagram color coding. We just want to see where power is coming from, where ground is coming from, etc., etc. All right, so right now there are 2 filaments on this bulb. So we have one right here on the left side of the bulb and one right here on the right side. Now we don't really know which one is high beam and low beam yet, but if we take a look at the schematic, we'll be able to find out. So just reading from left to right as we do here, let's start here from the left side filament. And we're just gonna follow the yellow brick road, so to speak, or the red one, and we're gonna travel until we see a clue. Now right now we already hit a clue. It says right high beam fuse. So we know that that's not the one we want. What we're really chasing is the low beam. Let's take a look at this right side filament. This looks a little bit more promising. So we're again just going to, in essence, follow the yellow brick road, and I know you can't see all of this diagram, okay? But it sort of comes around in a square pattern, and you know, honestly, for you guys, I'm just going to go ahead and draw a line straight up. There we go. On this diagram, there are lots of little bumps. These bumps are indicating to you that the wires are not touching. They are not actually connected together. It's sort of like a bridge, okay? So we just have to imagine that the wire's going over top of the other wire and not touching it or anything like that, okay? So we just keep following. So we just keep going. Oh, look at that. Right low beam fuse, number 66. Okay, we actually did check that, so we know that that's good. Now we're going to look at this schematic in a whole different way. So we found out that this right side filament is the low beam filament, and we know that this wire is the wire that we want to check for power, and that's great. Okay, but guess what? The ground side is equally as important as the power side is. So again, don't worry too much with all of this stuff at the bottom, okay? We're just going to put a big X through that. What we want to focus on is ground. So we're just going to color code our ground, which is going to be green, okay? And look, there's our little ground symbol right there, okay? Looks like a little rake. We've made some good progress. We know that the tan and white wire, which when you see the symbol or the letters TN/WH, that means tan with a white tracer. Tan wire with a white tracer. So a white line that just runs down the entire length of the wire. And our ground side is actually going to be black, or BK. BK stands for black. Okay, so those are really the only two wires that we're concerned about. We don't have to worry about the high beam wire, which is light green with a black tracer. Okay, we're not going to worry about that. Okay, so here we are. Here is the headlight bulb. Oh, finally, we finally get here after all of that instruction. Okay, so if you look here at this connector, and we don't need to disconnect it because we're just measuring voltage and voltage drop. If you look at this connector, hey, look at that. There's our tan and white wire that we were just looking at on the schematic. So we know that that is the power wire that goes to the light bulb. So fantastic. And then there's our black wire there in the center. That is our ground wire. All right? So, of course, these wonderful meter leads, the tips are just too wide to just stick in here and probe, back probe all of these connectors and wires. We would actually do a lot of damage that way, and we're trying to fix things, not break things. So that being said, we're going to use these nice T-pins instead. T-pins are very thin. I actually have some that are thinner than this, and you'll be using these in class, but just try not to poke anybody with it or yourselves. So we're just going to insert the T-pin behind the insulation, and we're just going to try to contact the connector that's inside. On the other side of this connector, the wire is no longer insulated, and therefore we're actually able to touch the copper portion of the wire, which is the portion of the wire that actually conducts electricity and voltage and all of those things that we're trying to measure. Okay? So what we can do here is just a quick available voltage test. Again, I take my black lead and attach it to the negative battery post. And I'll take my positive lead and just simply touch it to the pin. And we get a nice reading of 11.7 volts. Now yes, the key has been on this entire time. The headlights have been on for a little while. So our voltage is a lot lower than we really want it right now. The battery should be charged, and I really should put a charger on this thing. Okay, but we're going to hurry up and finish our testing so that we don't have to do that. Okay, now the next thing that we want to do is check our ground side. We want to see if our ground side has any voltage. Now, if you remember correctly, the ground side should not have any voltage, or very little, if any. So we'll go ahead and check that. Okay, so our meter is showing, gosh, 328 millivolts, or 0.328 volts, however you want to say that, whatever is easier for you to manage inside your mind. Okay, that's very little voltage. We had 11.7 going in, and now we only have 0.3 going out. That's good. Now we can actually measure exactly how much electricity the light bulb is using by doing a test called voltage drop. Voltage drop will basically tell us how much voltage that bulb is using by taking a reading of the voltage going in and a reading of the voltage going out. So it will take the difference. So now I can just take my 2 test leads and just attach them to either side of the pins. Okay, so I just had to readjust my pins. Some of them weren't contacting properly. But remember that when you are putting T-pins in the back of an active circuit so close together that you want to be sure that they never touch. If they touch, the amperage or the electrons will completely bypass this light bulb because it's so much easier just to go through the pins. And when that happens, the electrons are just flying back home. They are just going right back to the battery, and they're going at such a fast rate that it will actually burn up the wire. Now, hopefully it won't actually burn the wire. Hopefully our fuse protection will come into play, and our fuse will blow and we just have to replace the fuse. But you can really damage some stuff like that. Okay, and we will get a reading of, a voltage drop reading of 11.23 volts. All right, now you might think, okay, well, isn't the voltage supposed to be completely used by the headlight bulb? Well, that's true. We want most of the voltage to be used by the headlight bulb, but it's normal to use up some voltage on the power supply path, and it's usual to use up a little bit of voltage on the ground supply path. Okay, so let me just show you an example of what I mean. Now I can take voltage drop measurements of my power side as well as actual components such as the bulb. So remember, when you're doing voltage drop, just always be sure to have the circuit active and on. Okay, so for instance, I have the key on, headlights are on, everything is functioning properly as it should. Okay, so I can take my positive lead and touch it to the positive terminal here, or the positive T-pin, and I'm going to take my negative lead, and I'm actually going to put my black lead on the positive battery post of the battery, and that way I can see how much voltage is lost along that power side path. Okay, so power, more power. Alright, so I've got that hooked up, and as you can see, I'm only using not very much, 0.3 of a volt, okay, maybe 300 millivolts. Alright, and that's good. We don't want anything more than half a volt of voltage drop on any side of the circuit. When we're just talking about wiring and fuses and switches, we don't want to lose any more than that, because we need most of the voltage to be used to push electrons through that bulb. Okay, now let's not forget about our ground side. Our ground side is just as important as the power side. If there's a break anywhere in the circuit, you're going to have a problem. So we also should do voltage drop on our ground side. And yes, there is always going to be a little bit of voltage on the ground side as well. So now I'm taking one lead. It doesn't really matter what color it is. I'm going to take one lead, attach it to the ground side pin, and I'm going to take my other lead and I'm going to attach it to the battery negative post, or the black post on the battery. Okay, now let's see what we get here. Okay, we have about the same amount of voltage drop on the ground side as we did the power side. That's fine. No more than half a volt, or no more than 0.5 volts. Right here we have 0.3 volts. So that's good. Now it's easy to be confused between voltage drop and available voltage. But just remember that they really are two very separate things. Although we are measuring voltage all of the time, we're measuring it in different ways. Available voltage is just voltage available at any one point in the circuit. So if I want to measure available voltage here, I'll take my positive lead here, which is where I want to see how much voltage there is going in, and I would take my negative lead, my black lead, and put it on the negative battery cable. Okay, now I can leave this on the negative battery cable and just kind of point my red lead anywhere I want in the circuit, on the fuses, or any other place, and see how much voltage there is. If I want to see how much voltage is actually used, then I'm going to place both leads on the same side of the circuit. So I would attach this lead here to this positive pin, or the power side of the circuit, and I'm going to attach my other lead to the positive battery post. And the meter will take a difference between how much voltage is coming from the battery and how much voltage is actually getting to the bulb, because we will lose a little bit of voltage in that circuit, as you have seen. Now I can also do voltage drop on the ground side. I'm going to take one lead and put it on the ground side of the bulb connector, and I'm going to take my other lead and put it on the ground side of the battery, or the ground battery post. Voltage drop is the best test to use. Most manufacturers recommend it because you actually have the circuit live and active, and you see how much voltage is being used where. If you have too much voltage being used in the wiring, then you're not going to have enough voltage available for the bulb to light. And that's why we use voltage drop, more so than resistance or available voltage or anything else. Okay? Available voltage is also a very good test because we want to see how much is actually getting to the bulb, or how much available voltage we have at the battery, and so on and so forth.